Okay, so first we have to find the unit of Boltzmann constant. Now we know this equation PV is equals to nRT. In this R is the gas constant. If you divide R by Avogadro number, you get Boltzmann constant. Okay, so from here you can get this unit. Now the unit of R and K is going to be the same because this is a number and it won't affect the unit of this expression. Okay, so the unit of K and R is going to be the same. What is the unit of R? R is equals to PV by T. Here also N is a number, that is the number of moles. So now for P is the pressure of the gas. So you can write F divided by A, force divided by area. V is the volume, volume is L to the power 3, and T is temperature, Kelvin, in Kelvin. From here you can find the unit. Now for the next expression, that is the coefficient of viscosity. Now what is coefficient of viscosity? So first know something, discuss something about viscosity. So this is a surface. This is like suppose this is a cemented surface, and this is a drop of water or a layer of water. Okay. Now this layer consists of many separate layers on top of each other. We have considered like there are many separate layers on top of each other. Now you have seen that the layer on the top moves with maximum velocity, and a layer which is in contact with the ground has zero velocity. Okay, so like it is like that when there is a sea, the layer which of water which is in contact with the seabed, it is at zero speed, and the layer at the top moves with maximum speed. Okay, so now let's suppose that velocity here is 0 and velocity at a distance z from the surface is v. So if we move further dz distance, a little more distance upward, the velocity will be v plus dv. Now this ratio of change in velocity divided by change in distance perpendicular to the flow is called velocity gradient. Change in velocity, change in distance. This change is perpendicular to the flow. The flow is on the right side and distance we are taking in the vertical direction. Now the thing is that viscosity is a actually what happens that these layers, they try to stop the layer above them. That is, they provide a type of internal friction to the layers above them. So this layer is trying to stop this layer, and this layer is trying to stop this layer to move relative to each other. That is, they are opposing each other's motions. So it is a kind of internal friction force. Okay, so this force is proportional to area of contact. So each layer will be in contact to other, and they will have some common area between them. So this force is proportional to that area, and this is also proportional to this velocity gradient. So if we solve this, it comes out to be F is proportional to a dv by dz, and we have to replace this by equal sign. Okay, so this symbol, this is the proportionally constant, this is viscosity. So from this formula you can easily find the dimensions of this. Okay. Okay, now the next is the Planck's constant. For Planck's constant you can use this formula that energy of a photon is proportional to Planck's constant into frequency of that wave. Okay, energy of the photon proportional to Planck's constant into frequency of the wave. From here you can get the dimensions. Okay, now the next is the thermal conductivity. So for thermal conductivity, let's suppose this is a mm, metal rod of cross section area A. This is the cross section area A, and one end is at higher temperature and another is at lower temperature. So we know that heat flows from higher temperature to lower temperature. Okay, so in this we have considered a cross section uh, of surface. This is A surface, this is B. Now the temperature at this surface is T. So if we move a little distance dx, the temperature is T plus dt, or whatever you can consider T minus dt, because the temperature, if we go from left to right, will decrease. So it don't really matter. Now the rate of heat flow, the rate of heat flow, how fast the heat will flow, because the heat flows from higher temperature to lower temperature, how fast it will flow will depend upon the area, this area, because the more the area, the more will be the heat flow. It's like in current electricity, that the current depends on this area. If the area is more, resistance is less and the current is more. So similar here also, if the area is more, heat flow will be faster. And dt by dx, what is this dt by dx? Okay, so this is change in temperature per unit length, that is the dt by dx is the temperature gradient. So from this formula you can easily find the unit. You know the unit of heat, this is energy, this is time, this is area, and this is again temperature. This is temperature, this is not time, this is temperature, and this is distance. Okay.